vector is a quantity that's going to have two parts to it. It's going to have magnitude, which for us is mostly going to be length, but then when you use this in application, it's going to be speed. And it's also going to have direction, which we're going to show through an arrow. Now, it's represented visually by directed line segments. Now, you've seen these before. They look a lot like rays from geometry. They got an initial point, and they got a terminal point, just like all the angles we've been talking about. Now, they can be denoted two different ways. First way is through AB. And notice it's a ray in there, because this is a directed line segment, not a full line, because this guy doesn't have an arrow. It also can have a lowercase letter denoting the vector, which in my case is D, always a lowercase letter. Now, I just mentioned a second ago, you're going to use these heavily in physics. And the reason why is because this allows us to talk about two different forces that are acting upon an object. And we can talk about how each force acts on it and what the resulting force is going to be. Last thing, when are vectors equal? Vectors are equal if and only if they have the same magnitude, so they have the same length, the same speed, and they have the same direction, meaning they're going the same place. Now, this is an if and only if, so it can go both ways, meaning that if they're equal, then we have the same magnitude and direction, and if we have the same magnitude and direction, then they are equal. Now, we're going to look at specific vectors that are equal with examples. All right, example one. We're going to look at which vectors are going to be equal to vector PQ. Now, here's how I drew vector PQ. I started with the initial point P. I went right 3 up 2 to the terminal point, and then drew my directed line segment. I said it was going that way. So go and copy that down, and then get down these 4 vectors. We're going to need them. Now, I didn't put them in any order, so it doesn't matter that V is above W or that V is to the right of W. Doesn't matter. I put it in random order. Go ahead and copy it down. Vectors are equal, we got to look at 2 things. We got to look at their magnitude, which is the length, and we got to look at their direction. Well, for the direction in PQ, I'm noticing that it went right and it went up. And that's about as specific as we're going to get for now. For the magnitude, well, that'd be the length. Well, if you think about it, just visually, we could draw a right triangle with this. So I'm kind of thinking about the Pythagorean theorem with a 1, 2, 3 and a 1, 2. So a side of 3 and a side of 2 giving me my distance. So once again, the direction is going right and up. And the distance, to me right now, we're going to get way more formal with this later, is right 1, 2, 3, and up 1, 2. Let's look at all of our other vectors over there. Let's start with W. Well, noticing W, well, I notice it's also going right and up, so it has a possibility of having the same direction. Now for the same magnitude, I wanted to go right 3 and up 2. Notice it goes right 1, 2, 3, up 1, 2. So for which vectors are equal to PQ? W absolutely works. Had the same magnitude, had the same direction. Now let's look at B. Well, for B, I'm noticing it went right 1, 2, 3, and down 1, 2. So I'm noticing that its magnitude is going to be the same, but this vector went right and then up. That one went right and then down. It has a different direction. So it is not equal. Now let's take a look at V. Well, for V, I'm noticing it went right and up. So it at least has a shot for being the same direction. Now for the same length, though, I'm noticing it went right 1, 2, 3, 4, 5, 6, up 1, 2, 3, 4. And look at it. There's no way that that length is the same. So they're not equal either. Now let's take a look at C, all the way in the corner. Well, I'm noticing that one also went right and up. And it went right 1, 2, 3, up 1, 2. So C also works. Those are the 2 vectors that were equal. Alright, so we're going to begin our next one, geometric interpretation of what vectors are. Now, the first part we're going to start with is how to add vectors geometrically. Now, the way we're going to do it is we're going to position the vectors so that the terminal go ahead and copy down example 1. We're going to draw v plus w. So we're going to add vector v to vector w. Now notice the way I'm drawing vector v is right 1, 2, 3, 4, 5, 6, 7, up 1, 2, 3. And w is right 2, down 1, 2, 3, 4. Now notice it says draw v plus w. So I'm going to start off by redrawing v. So when I redraw v, it was right 1, 2, 3, 4, 5, 6, 7, and up 1, 2, 3. So redraw it right 1, 2, 3, 4, 5, 6, 7, and then up 1, 2, 3. There's vector v. Now notice it says position the vector, so the terminal side of the first coincides with the initial side of the second. So we need to draw the initial side of w right on top of the terminal side of v. So w, notice, was going right 1, 2, and down 1, 2, 3, 4. And I'm going to start right on the terminal side, and then go right 1, 2, and then down 1, 2, 3, 4. And there's my vector w. And then read the last part. It says, then connect the initial side of the first, right there, with the terminal side of the second. Also known as just connect the dots. So let's connect the dots. Now remember, it's a directed line segment. So this guy gets the arrow. And the way you tell me this is your answer is by labeling it v plus w. So now we're going to take a look at subtracting vectors geometrically. We're going to draw vector v minus vector w. Now, what this really means is v plus negative w. Well, that brings up the question of what negative w really means. Well, negative w is the vector with the same magnitude. Remember, that's the length. So the same length, but opposite direction. So if you look back at example 1, vector w was going right and then going down. Well, we got to go the opposite direction. So instead of going right, we're going to go left. And instead of going down, we're going to go up. Now let's do this thing. Start by drawing vector v. Well, remember, vector v with right 7 up 3. So from here, let's go right 1, 2, 3, 4, 5, 6, 7. Up 1, 2, 3. And then we need to do negative w. Now remember, it has the same magnitude, so the same length, but opposite direction. So make sure instead of going right, you go left 2. So from here, left 1, 2. And then instead of going down, we're going up 4. 1, 2, 3, 4. Draw it there. And then remember how we always finish these. Connect the dots. There we go. That one. Now take a look at example 3. Go and write that down. We're going to draw b plus c, and then we're going to do c minus b. Now b, notice, is going right 1, 2, 3, 4, 5, and down 1, 2, 3. C is going left 1, 2, 3, and down 1, 2, 3, 4, 5, 6, 7. Now remember, to do b plus c, start by drawing b. Now b was going right and down. So let's go. I'm going to go right. 1, 2, 3, 4, 5, down 1, 2, 3. 1, 2, 3, 4, 5, down 1, 2, 3. Redrawing b. And since it's plus c, we're just going to take c normally. And c was going left 1, 2, 3, and down 1, 2, 3, 4, 5, 6, 7. So we're going to go left 1, 2, 3, and down 1, 2, 3, 3, count. 1, 2, 3, 4, 5, 6, 7. Alright, so now we're going to look at example 3. I want to draw b plus c, and then later draw c minus b. Well, let's start with b plus c. That means we're going to have to start with drawing b, and then, well, add c on at the end. Well, b is going to be 1, 2, 3, 4, 5 to the right, and down 1, 2, 3. I'm going to redraw that right here. So I'm going right 1, 2, 3, 4, 5, and down 6, 7. So from the terminal point, we're going to go left 1, 2, 3, down 1, 2, 3, 4, 5, 6, 7. And connect the dots. That's going to be B plus C. Now, if we want to do C minus B, we got to start with C and then change the direction of B. Well, starting with C, we're going to go left 1, 2, 3, and down 1, 2, 3, 4, 5, 6, 7. You got to have that memorized by now. So left 3, 1, 2, 3, and down 1, 2, 3, 4, 5, 6, 7. And then we got to go the opposite direction of B. Well, B was going right 1, 2, 3, 4, 5. Well, now we're going to need to go left. And it was going down 1, 2, 3. Well, now we're going to need to go up. So we got to go left. We got to go up. So let's go left 1, 2, 3, 4, 5, and then up 1, 2, 3. Right here. Drawing our direction 1 second. And then remember, we end by connecting the dots. So it started here, goes all the way to the end. Here's the U try. Make sure you draw all 3 vectors and give these 4 a shot. I'll put the answers up in there.
Alright, there are the answers. Go ahead and check yours.
So now we're going to take a look at how to multiply by a scalar. Now, scalar is a new word. All of this is a number. That's going to become really important using in physics, and then we talk a lot about that in calculus also. Now, all scalars do is they change magnitude, not direction. So, we're going to draw 2G. Now, if you think about it, 2G is just, well, G plus G. Well, there's G right there. So let's draw G plus G. Well, that's going 1, 2, 3 to the right, and 1, 2, 3, 4 up. So let's redraw that. 1, 2, 3 to the right, 1, 2, 3, 4 up. There's the first G, and it says plus G again. So let's do it again. So write 1, 2, 3, and up 1, 2, 3, 4. And connect it. Now the interesting part is when we actually connect this, going from the starting point to the ending point, notice how it followed along that vector the whole time. That hints to me that there's a faster way to do this. So let's take a look at it, see if we can find it. Well, originally G was just going right 1, 2, 3, and up 1, 2, 3, 4. Well, now we're going right 1, 2, 3, 4, 5, 6, compared to 1, 2, 3. 2 times 3, 6. And then up 1, 2, 3, 4, 5, 6, 7, 8. Compared to going up 4. Once again, 2 times kind of the vertical distance. So it looks like maybe redrawing it twice, yeah, that was nice for here, but like when we get to example 2 and it's 5G, that's going to get really tedious. So we're going to try to want to use this quicker way to knock it out really quick. So let's go to example 2, drawing 5G. Now remember, G was going right 1, 2, 3, and up 1, 2, 3, 4. So think about it. If we're going to draw 5 of the G's, we're going to be going right, well, 1, 2, 3 times 5. We're going to be going right 15. And then up 1, 2, 3, 4 times 5. So we're going to be going up 20. So right 15, up 20. Here we go. Starting here. Right 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 right there. And then up 20. Up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So let's line that up. To there. Connect our dots. That is 5G. Because we the amount of G 5 times up in that direction. Now let's look at how to draw negative 3a. Now, first of all, the scalar is the 3. Well, that means we're going to go the distance of a 3 times. But then the negative is going to change the direction. So we notice that a is going right 1, 2, 3, 4. So right 4. And down 1. Well, first of all, we got to change the direction. So I know instead of right, we're going to be going left. And then instead of 4, well, we got to do that 3 times. So we're really going to be going left 12. 4 times 3. Or 4 plus 4 plus 4, if you want to look at it that way. We're going down 1. Well, now we need to go up. And instead of going up 1, we got to do it 3 times. So we're going to be going up 3. So we got to draw the vector that goes left 12 and up 3. Let's do that. Starting over here. Let's go left 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Then down 1, 2, 3. Right there. And that is negative 3a. Now we're going to combine everything. So we're going to take the additions, we're going to take the subtractions, and we're going to take the scalar multipliers and geometrically draw them together. So notice vector h, vector m, and vector p. Example 1. We're going to draw 2h plus 3m. Well, let's start with 2h. Well, h went right 1, 2, 3, 4. But we got to remember we have a scalar multiplier of 2. So we're really going to go 1, 2, 3, 4 times 2 is 8. And then up 1, 2 times 2 is going to be 4. So we're going right 8 and then up 4. Starting from here. Right. 1, 2, 3, 4, 5, 6, 7, 8. Up 1, 2, 3, 4. And we got a point right there. From there, we are going to do 3m. Well, 3m is going to take the distances of m multiplied by 3. So it's going right 2 times 3 is now right 6. 1, 2, 3, 4, 5, 6 out here. And then it goes up 1, 2, 3 times 3 is going to be up 9. So up 1, 2, 3, 4, 5, 6, 7, 8, 9. Right there. Originally, that was in there. That was in there. And then remember, connect the starting point to the ending point. Start from here. Opposite there. This guy is 2h plus 3. Now let's look at something a tiny bit more complicated. We're going to go h minus 2m plus 3p. So we got to remember when we do the minus part, we got to change the direction also. But for the h, let's just start with that. That one was right 1, 2, 3, 4, up 2. So right 4, up 2. Right, start here. Right 1, 2, 3, 4, up 1, 2. There we go. We got ourselves h. Now we need to do negative 2m. So the first thing I'm thinking about is, well, n was going right, now it's going to go left. Well, originally it was going right 1, 2. So it's going to go left 4, because we got to multiply by 2. So let's go left 4. Left 1, 2, 3, 4. So we're there. And then m did go up 3. We got to change directions. It's going to go down 6, because we got to multiply by 2. So down 1, 2, 3, 4, 5, 6. And like that is minus 2m. And now we need to go plus 3p. We're looking at p. P went left 1 times 3. We're now going to go left 3. Left 1, 2, 3. Notice I went from the terminal side.
Go ahead and check your answers.
So next thing I want to look at is vector addition commutative. Well, remember what commutative means. Commutative means that we're able to move things around and we get the same expression. And if we think about it, 3 plus 5 equals 8, just like 5 plus 3 also equals 8, because addition is commutative. So now we want to know, is vector addition commutative? So we're checking, is v plus w the same as w plus v? Well, let's find out. Let's start with v plus w. Well, v was going right 2, up 1. So I'm going to go over here and go right 2, up 1. There's v. And this is plus w. Well, w was going right 1, 2, 3, and up 1, 2, 3, 4. So right 1, 2, 3, up 1, 2, 3, 4. W. So then v plus w will be where we connect these. Right there. V plus w. Well, now let's do w plus v. And what I'm going to do is I'm going to start here and see if I get that same line segment in the middle. So let's do w. Well, w